So this is the first lesson where we're going to take a look at essential web concepts. As part of this first lesson, we're going to take a look at what the web really is, and we're going to take a look at it from a number of different perspectives. The web really is actually a set of protocols and a set of applications, but commonly and colloquially we refer to the web as a combination of different things. We have the physical communication network that allows a browser such as Google Chrome or Apple Safari to connect to websites, and that includes physical communication networks and networking protocols like 4G on a cell phone, 802.11 that you would have on a Wi-Fi connection, T01 that you would have perhaps on a line, on a physical actual wired network connection, which you might have somewhere in a company or the university. Then of course is a collection of application communication protocols that determine how the browser communicates with the web server. That includes communication protocols like HTTP for loading web pages, SMTP for doing email transfer, and FTP for doing file transfer. Then of course from a development perspective and the actual rendering of web pages, there is a number of different languages, programming languages involved, and that includes languages like HTML for describing the content of a web page, JavaScript for allowing dynamics of that content, CSS for defining the style of the content, PHP for doing server-side interaction with databases and things of that nature, among many other languages. Now this course is concerned primarily with web development. We're not going to dig deeply into networking. We're not going to go take a look at the communication protocols, browser development, and so on. We're really worried about figuring out how we can develop dynamic websites that are appealing to potential customers. Now web development is the process of creating websites and web applications using one or more programming languages. And that includes languages like HTML, CSS, JavaScript, PHP, and so on. Now web development involves both client-side and server-side programming. So on the client side we have the browser. That's what you actually use to interact with your website. So when you load Google Chrome or Safari or Firefox or Internet Explorer, that's your browser. Within your browser you view web pages. When you view a web page, you connect first to a web server from which you get the page. So the server is the server that contains the page. Your browser becomes the client because it requests pages. And so this is what's often referred to as a client-server architecture. And there's both development of code on the client, code that runs within the browser, and code that runs on the server. Now what you need to learn to be able to develop web pages and web applications depends. It depends on whether you're doing primarily client-side development or server-side development. Now of course for a real web application you're going to have to do both, and in this course we're going to take a look at both of these, server-side and client-side programming. Now for the client-side, meaning your browser, you need to know at least HTML, CSS, and JavaScript. And we're going to take a deep look at all three of those languages. Now for server-side development, you'll need to know one or more programming languages in which you can develop server-side scripts that develop what we call dynamic content and also interact with databases. Now that includes languages like PHP, Microsoft's ASP.NET, Java, Deluge, Ruby, Python, C#, among many others. Now in this course we're going to restrict ourselves to one of those server-side languages, and that's PHP. And in fact we're only going to scratch it at a very, very high level. We're really only going to take a look at it from a very high level perspective because PHP is a real programming language and it requires some pretty good programming understanding before you really can dive deeply into it. And that's beyond the scope of this course. So before we dive into more of the development part, let's revisit again this notion of browsers and web servers. So like we already said, the web is a simple client-server architecture where clients send requests for documents to servers using a particular request protocol. And the request protocol they use is called HTTP, which stands for Hypertext Transfer Protocol. It's a set of commands that a browser can issue to a server to get certain pages. So there's certain conventions that the browser uses to make that request and to specify which document the browser wishes to get from the server. Now, the details of that protocol are not important to us. What's important to us is that a computer with a browser is called a client. That computer within the browser makes a request for a web page. The service then locates that web page and sends it back to the browser. And the document is almost always an HTML document. And the browser then renders that document. It displays it. So the key is that browsers request documents from web servers and that the documents are generally HTML. Now, it doesn't have to be HTML because most browsers can also render documents in the PDF format, and they can also render non-text documents, if you will, such as images, videos, audio files, and so on. Now, most documents are stored directly on the server, and a programmer develops those pages, those documents, and then stores them on the web server in order for users with browsers to be able to access those documents. But as we're going to see later on, you can also generate pages or documents on the fly. That means you write a program which will retrieve content from a database and then manufacture a page or a document and then send that manufactured document down to the browser. The browser doesn't care whether it gets a static document or what's called a dynamic document. Dynamic documents are those documents that are generated when requested and are generated on demand. Now, web applications and dynamic web servers like Amazon, and pretty much any web server today, uses that technology. Imagine that you look at a product page on Amazon, or think about a Facebook page. There's not going to be some programmer sitting somewhere in Redmond or somewhere out in San Jose building web pages and updating content on a web page every time somebody enters a post or a new product appears in Amazon's inventory. Instead, all that information is put into a database, and a program extracts the information from the database and then manufactures a document that contains the information. And that's a document that's going to be sent down to the browser. So that, of course, means that the HTML document, or what's also often called the HTML page, the term document and page are used interchangeably in web development. That document always contains the latest information. Now, the browser always gets an HTML document. It doesn't care whether that document was statically built by some programmer or whether it was dynamically generated by some program. Now, we're going to learn how to do this dynamic document generation a little bit later on when we discuss PHP. Now, to build dynamic pages, like I said, requires programming in a programming language. And PHP is probably one of the most common language. However, other languages would include Java, ASP.NET, Deluge, Ruby, C#, among many, many others. There's a number of new programming languages appearing all the time, like Silk and many others, that make that construction of dynamic pages easier and easier. Now, one of the key concepts in being able to retrieve a document from a server is the URL. So let's go take a closer look at this with an example. All right, so here I've launched Google Chrome, and I'm typing into the address field a URL. Now, typically the URL looks something like www dot the name of some company, a website dot some top-level domain, commonly COM, which stands for commercial or company. So, for example, if I type in www.w3schools.com and then hit enter, what I'm doing is I'm instructing the browser to go to the computer named w3schools.com somewhere in the internet, and we'll talk more about later on how exactly it finds that, and requests a document. Now, since it did not specify a document to retrieve, the web server at w3schools.com returns the default document, which is almost always the document contained in the file index.html. We don't know this because it's actually a server configuration, but it almost always is a document called index.html. We'll see more about that when we start building custom websites and custom web pages in pure HTML. But if I do that, browser goes off, document comes back, browser renders a document and displays it. And there it is. Now you can actually look at what the document looks like by clicking the right mouse button and picking View Page Source, or pressing Ctrl U for that matter. And you actually see the entire HTML source that makes up that page. All the HTML, all the JavaScript, and all of the CSS style specifications. So again, what happens is that the browser simply receives a document, recognizes that the document is in HTML, and then uses the rules for rendering HTML to display the actual web page, the actual document. Now, what you also see, and again, let me take a look at the page source with you here for a second. I'm going to do this in a non-link part. What you will also see here is that this is, if you notice here, encoded in HTML. Here's the title of the page and a number of other important pieces of specification. Now, this encoding is done in a language called HTML. And in fact, we're going to study exactly what those tags mean. We're also going to study how to write these types of functions and how to do these types of style specifications. But we're going to talk more about that later on. For the moment, remember that the web is a client-server architecture. On your browser, you specify the name and location of a computer and a document, and you instruct the browser to fetch that document and then display it. So let's take a closer look at what that document looks like. So the document location is specified in something called a URL, a Uniform Resource Locator. It's a very specific way of specifying documents on a web server. And it generally involves the name of a computer, dot, the name of the company with its top-level extension, followed by the name of the document you wish to retrieve. So if you don't specify the name of the document, the default document is almost always index.html. By the way, notice that the extension here at the end does not have to be com, does not have to be commercial. It could also be .de, which happens to be the country extension for Germany. So the URL is a very particular format. And in fact, this is the specific format that a URL has to take. It is a protocol that the browser uses to communicate with the web server, followed by a colon and 2 forward slashes. Then a domain name or the IP address of that computer on which you wish to from which you wish to retrieve the document, followed by a colon, followed by the port number, which is kind of like a message box, or a room number, if you will, indicating which web server on that computer you wish to communicate with, just in case it runs more than one. Followed by a forward slash, the path to the folder that contains the file you're looking for, or the document you're looking for, followed by a slash, and then followed by the file name itself. Now, the protocol is generally HTTP. So it's always something like HTTP://. That's probably the most common one. There is also an alternative version called HTTPS, which is a secured version of HTTP that encrypts all the traffic so that hackers and other third parties cannot intercept in some fashion your request and from that get private information like passwords, credit card numbers, and things of that nature. That's going to become very important when we later on discuss form submission, where we might be transmitting from a browser to a server private information. So HTTPS then allows us to encrypt that information so that no third party can intercept information and read it. But normally it's HTTP. In fact, if you leave out the protocol and you don't specify it, by default it is HTTP. But you can also specify file, which allows you to load a file that's actually on your computer, so it doesn't actually go over to a web server, but it goes on your computer. You can use FTP for downloading a file from some remote computer, news for reading news groups, mail to for specifying an email address, and so on. We'll talk more about them as we get a use for them, but for the moment, we're going to restrict ourselves to HTTP as the default protocol. The next part is the domain or IP address, which is the location of the computer. Now, generally it is something like www.yahoo.com or .neu.edu. That's a company followed by a top-level domain. The com part is the top-level domain. Yahoo would be the company name. It's also often referred to as a domain name. Now, the www prefix is actually only a convention, and it's very important to realize that that is not really an integral part of the web. Whether the web server is called www or not is actually irrelevant. By convention, over the last 20 years or so, www refers to the company's computer that contains the company's main web server. But it doesn't have to be that. For example, our course website is at is1500.weebly.com. There's no www involved there. Instead, our computer is called, or that domain, it's called a subdomain actually, is called IS1500. Now the .com part is your top-level domain, and that's the most common one, at least here in the United States. However, when the web was first built, there was an accommodation for other organizations besides companies, so other top-level domains exist, including mil for military, gov for government websites, edu for nonprofit educational institutions, .org for nonprofit organizations that are non-education based, and .net for organizations that have to do with the management of the internet itself. Now later on, ICANN, the global group that decides on what the top-level domain names are, decided to include top-level domain names for countries to make it a little bit less crowded, because after all, what would you do, for example, if you had a military organization in Germany that wants a website? You really shouldn't be called a .mil, because that refers to a military organization in the US. So in order to be not as US-centric, ICANN developed a set of top-level domains for countries. For example, .de for Germany, .ch for Switzerland, .me for, I forget what the name of the country is. I think it's some island. TV is Tivoli. That's a country, I think in the Pacific. What's actually kind of interesting is .me, .tv sound like they're pretty interesting high-level domains, but actually just turns out to be high-level domains of countries. There's also categorical domain names like .biz, .info that are also used now because we are no longer able to support all the websites under .com. Now, how do you get one of those domain names? Well, if you have a company and you wish to register a top-level domain name, you do that through a registration service. And the registration service eventually registers the domain name with ICANN and adds it to what's called the Domain Naming Service, or DNS, which is kind of like a global phone book, if you will, a global directory that contains all the top-level domains and where they're located. Now, the most well-known domain registration services are GoDaddy, Yahoo, Weebly, and of course there's many others out there. Generally, you go to them, you check to see if the domain name you're interested in exists. If it does not exist, you can have them reserve it for you and then pay an annual fee. It's generally somewhere around $30 or so. Sometimes the services charge a couple extra dollars to maintain the registration. Very important, by the way, if you do not maintain the registration after it expires, anyone else can claim your domain name. So if you have, for example, a company and you've invested heavily in promoting that company, you have marketing materials, and then you forget to pay your registration, your DNS bill at the end of a year, your top-level domain for your company expires and anybody else can claim it. In fact, there are companies out there who will run robots to check when a domain name service registration expires, and then as soon as it expires and it hasn't been claimed, they will claim it immediately. And then, of course, if you find out, let's say it's you expire, the domain name expires on January 31st. You have a bad credit card on file, or your system administrator left, or you have been too busy because you are on vacation, or you've been doing some other work, and you forget to renew your domain name for your company, beststuff.com, or whatever you're going to call it. Well, on February 1st at 12:01 a.m., that domain name, bestcompany.com, goes back into the open market. Typically, some robot will pick it up, and it will grab the domain name, and now they will register it. Now, you were going to come, go to your office on February 1st, and you look at your website, and it's gone, because somebody else now has the domain name, and it's routed to their computer. Now, if you want it back, you will very likely be able to contact them, but they probably want some kind of a fee for it. They basically hold your domain name for ransom. And sometimes they charge you a couple $100, sometimes they charge you a couple $1,000. They might even charge you $10, $15, or $100,000. So you then have to make a decision. Do I pay them because I've invested so much in marketing, or do I let it go and rebrand myself on a different company name? Clearly, that is something that you want to avoid. So it's very important that you keep a very tight handle on your domain names, your registration dates, and make sure they're automatically renewed and you have a valid credit card on file. Also, if you have somebody within your company, do that. Make sure that when that person leaves, somebody else now takes over the administration of the domain names. Now, so far we've only talked about domain names, but it turns out, like with pretty much everything else in the world of computing, things are not really being addressed and tracked with names, but rather with numbers. The actual computers on the internet are identified through a number rather than a domain name, and that number is called an IP, or Internet Protocol Address. Now, generally it has the form right now of 4 numbers, and the numbers are always between 0 and 255 because they correspond to 8 bits. And if you do a little bit of binary math, you will find that with 8 bits, you can represent 2 to the power of 8 different decimal numbers. And 2 to the power of 8 happens to be 256. So you go from 0 to 255. So each one of those numbers is between 0 and 255. Although it almost never is in the beginning 0 or 255 because they have special meanings. So for example, there might be something like 192.168.0.12. or 10.31.103.201. Now, how do you know what your IP address is? Well, quite frankly, in most cases, it's completely irrelevant. But if you do want to find out, you can do that by actually using Google. There's actually a number of ways you can do this. You can go to the command line. You can go and, for example, on the DOS, Windows, I should say, you can launch a DOS shell, and you can go ahead and type in the command ipconfig. That'll give you the IP address of your network connection. But it's actually a simpler way of doing this. And that is to go and use Google. So let's go back to our browser. Now in your browser, all you have to do, or in your Google, it actually doesn't have to be Chrome, by the way, it can be Safari too. Just go to google.com and type in what is my IP? And it will go ahead and give you your computer's public IP address. That is the number, that's the address by which your computer is currently known. So in this particular case right here, I'm known under the IP address 66.87.67.57. Now, of course, every single computer in the network is going to have a different number. And that number might differ dramatically depending on from where you're connecting. So the first 2 numbers actually indicate the network, which is almost always your ISP. So if you're connecting from the university, you're going to get an IP address in the beginning that is based on our internet provider. If you do this at home, let's say through Comcast slash Xfinity, you're going to get the first 2 numbers as the high-level IP numbers for Xfinity Comcast, and so on. Now, without getting into too much detail, most computers use what's called dynamic IP addresses. So in your case, let's say on your laptop you connect to one of the university's Wi-Fi hotspots. At that point in time, you're going to be assigned an IP address temporarily. That's done through a service called DHCP, the Dynamic Host Configuration Protocol. So basically, every time you connect to the university network through Wi-Fi, or if you go to Starbucks and you connect to Wi-Fi, or if you go home, dorm room, and you connect to Wi-Fi, you're going to get a temporary IP address from your Wi-Fi hotspot you're connecting to. So your IP address is not fixed, it's dynamic. Now, in the case of web servers, that's not the case. Web servers require a static IP address. So when you have a web server, that needs to be a computer that's on the internet permanently and has a fixed IP address. And that's one of the reasons why you rarely host a web server, or a website to be more precise, on your own computer, on your laptop, on your MacBook, or whatever. It's typically on a server computer in a dedicated server situation connected permanent to the internet. Now we'll talk more about later on how you get one of those and how you set this up in practice. But we got to talk a little bit more about this notion of looking up domain names and IP addresses. So what happens in practice actually is this. When you want to get a web page and you type in something like www.w3schools.com, the first thing a browser has to do is fetch the IP address, or get the IP address of that w3schools.com server. So it does that by contacting a special server called a DNS server, a domain name server. So it gives it the domain name, w3schools.com, and it asks the DNS server, hey, what's the IP address for w3schools.com? The DNS server has a very large directory of all of the web servers in the world, along with the IP addresses. By the way, if it doesn't, it's going to go and talk to some other DNS server, and eventually, at some point in time, if it exists, it'll find it out. By the way, if you register a new company, it may take 24 or 48 hours before your DNS entry is propagated to all the DNS servers in the world. So sometimes when you register a new website, don't be surprised if you type in www.mynewcompany.com and it doesn't show up. That's because it's not yet been propagated through all the DNS databases. Now, once you have been able to look up the DNS entry, the client, the browser, gets the IP address. It can now make an HTTP request with that IP address and go to that server that contains the document you're looking for. So actually going to a web page is a two-step process. First process is to find the IP address from a DNS server. Second process is to find the actual page on that computer. So that's one of the reasons why you need a DNS server as part of your setup. Good news is when you connect, let's say, to your Wi-Fi at home, university, and so on, part of your configuration of your computer is to get an IP address and to also get the location of the nearest DNS server. Now I want to talk about something very practical, and that is when you start building larger websites, you're going to find that your URLs get very, very large. You're going to find that you're going to have documents, you're going to organize them in folders, you're going to organize the folders in other folders, and so on. So it becomes often relatively unwieldy to deal with very large URLs, particularly if you want to email URLs, if you want to include them in tweets, if you want to publish them on web pages, or if you just want to keep your web pages clean. So we often employ when we do web development something called URL shorteners. One example is bit.ly. You go to bit.ly and you type in the URL of a very large URL. So let me actually just grab this here for a second. You can do this yourself too. You can follow along. Let me copy this. Let me go to bit.ly. And once I'm there, I simply paste the URL that I have into their box. And it gives me, in return, a small, shorter URL. And that's the one I would now use in the future. So going forward, I will use this small bit.ly /1ROA5VX. And by the way, it's case sensitive, so be sure to distinguish between uppercase and lowercase letters. They're different. But it's a heck of a lot easier. Bitly is not the only one. There's also Google, GOO.gl, and many, many others. Facebook has their own. Twitter has T.co. There's a number of other ones that you can use that are typically very, very short and come up with very, very short URL mechanisms. But that's just a way for you to help you. Not important, not necessary for building websites, but it's convenient. So let's review this whole sequence of how you connect to the web, how you connect to a web server, and how you get a web page from a remote web server. So you have a user sitting in front of a computer with a browser. The user types in the URL of the document they wish to get from a web server. The browser then formulates an HTTP request for the document, first does a DNS lookup to get the IP address, and then sends it to the web server specified in the URL, via the IP, of course, after the DNS lookup. The server then looks for the document, or, if you specify the name of a program, runs the program to generate the document. Server then sends back the document to the browser. The browser then renders or displays the document based on the language in which it was encoded, which is almost always HTML. So that's sort of the mechanics of it. Now we're going to talk a little bit about how you actually connect to the internet itself. So let's say you have a laptop, or you have a cell phone, or you have a computer, and you want to connect the computer to the internet. How do you do that? We've kind of glossed over that part, and we said, well, assume you're connected to the internet. But how does it actually work? Well, you need to connect to the internet through a network. So you need to have some physical connection to that network. And there's a number of different possibilities for this. You can use a mobile network. Typically that involves using 4G, 4G LTE, 3G, and so on. And in order of speed, 4G LTE is the fastest, followed by 4G, followed by 3G. We almost never use 3G anymore because it's simply too slow, but keep in mind that in other parts of the world, South America, certain parts of Africa, and so on, cell networks are not as ubiquitous, and so they often still access the web through a 3G connection, which means your website better not have very large pictures, no videos, no ads, because it's going to make it very, very slow to use your web page or your website. So be very mindful that users don't always have fast connections to the internet, and therefore your website has to be lightweight to make sure it doesn't take a long time to download the content of your pages. We'll talk a lot more about that later on when we take a look at multimedia content, because it does have an effect on how you encode particularly images. Now, besides a mobile network, which you might use in a cell phone, or if you're using a cell phone as a hotspot to connect your laptop to your cell phone to the internet, besides that, you can also use telephone, cable networks, or wireless networks. So at home or in an office, you might want to connect through the telephone. You actually plug a wire from the wall into your laptop, and you connect through either DSL, it's called the digital subscriber line, or ISDN, an integrated subscriber digital network. Quite frankly, relatively rarely used in this country. Relatively prevalent in Europe, but in this country it's more likely that you connect to your network, to the internet via cable. At home maybe you have Comcast, Xfinity, RCN, AT&T, Verizon, Fios, and so on. So you connect over the cable network. But the assumption here is that you actually physically plug your network into your computer through a cable. Now that's actually, again, relatively uncommon these days. In fact, if you look at your laptops, you might discover that most of your laptops don't even have a network plug anymore. They used to have a connection. Looks kind of like an old style phone jack. It's called an RJ45 connection for Ethernet, but it's relatively uncommon. If you look at the machines in the lab, in fact, if you look in the back of the machines, they all are plugged into the internet through an Ethernet network over what's called an RJ45 twisted pair cable. They're actually physically connected, which makes the connection relatively fast, very stable, and there's not sort of a fast, slow type of connection. It's always relatively stable connection. But that's not a possibility if you have a laptop. It's not a possibility if you're in a mobile classroom, if you're at Starbucks, and so on. In that case, you almost always connect to the internet through a wireless connection. And in fact, that's probably the most common way of doing it, because most computers today, certainly none of the tablets, include a physical way of connecting to the internet. So we almost always connect through what's called Wi-Fi. Wi-Fi stands for wireless fidelity, and it follows a particular protocol. And the protocol means that this sort of determines how the radio signals are encoded between your laptop and what's called a wireless access point. And that encoding protocol is the 802.11 protocol specified by the IEEE. And there's some sub-protocols, 802.11b and C and N and so on. You don't really have to know the details. Most wireless access points pretty much do any protocol. Most laptops include the latest protocol. If you connect to NU-Wave, if you connect in here through CCIS, if you connect at Starbucks, if you connect in a coffee shop, at the airport and so on, you are connecting through Wi-Fi. And what actually happens in that case is that you connect as follows. You basically connect your tablet, your laptop, and so on to your Wi-Fi network. That's done through a Wi-Fi access point. It's typically some kind of a box you have in your house, or it's some kind of a box that's mounted somewhere on the wall. Now that Wi-Fi access point almost always includes a Wi-Fi router that then has a connection to a modem, which then connects to the actual wired network. So think about this at home. At home, you very likely have internet access through, and I'll pick a common one in this area, Xfinity, Comcast. So Comcast puts a cable wire into your house, the same cable that you're going to use to plug in your TV. You then take that cable and plug it into a special box that Comcast gives you. It's called a Wi-Fi modem router. It's actually three things in one. It contains the modem, the Wi-Fi router, and the Wi-Fi access point all in one box. It used to be three boxes. Today, Comcast gives you one box. So by the way, that's AT&T and Verizon. They do the same thing. You then connect to that Wi-Fi router, typically on a secure connection. That means you have to type in a password that encrypts the traffic so nobody can intercept it and nobody outside your apartment or house can access it. You connect your laptop to that. All of your web traffic goes over the radio waves, over the air to the Wi-Fi access point, and that then eventually gets converted to the right signal to go to your cable provider. Your cable provider accesses what's called the Internet Service Provider, the ISP. And like I said today, that's almost exclusively AT&T, Verizon, Comcast, RCN. Now the ISP then, let's say Comcast, has then its own network connection to other networks. And we call those other networks generically the Internet. It's not important how the actual transmissions work, but that's how you connect to the Internet. Now, if you are on a laptop or if you are on a cell phone, in that case, you're connecting to the Internet through most likely a 4G radio network. That means you connect into a built-in modem inside your cell phone to some kind of a tower that connects you to the satellite system, which then connects you eventually back to Verizon, Comcast, T-Mobile, Cricket, Metro PCS, Sprint, whatever, to the Internet. Or, like we have in the classrooms, you have computers directly connected over a fixed wire local network, eventually through a T01 line, through some kind of provider that we pay for it at Northeastern, into the Internet. So, at the end of the day, whether you connect a mobile network, Wi-Fi network, fixed network, satellite network, you all end up eventually being connected to that same global network. So that's how, for example, you can, from a phone, talk to your laptop, or your laptop can talk to some kind of a computer somewhere. They all eventually exchange the traffic through the Internet. So that's how it works at the low end, at a high level. Now the good news is we don't need to know most of this. What we need to know is, one, how do we connect to the Internet? And very important, how do our targeted users, our audience of our websites, connect to the Internet? because we have to be mindful of their connection, because different connections have different speeds, and very important in some cases that traffic is metered. For example, most of your cell phones only allow you to have 2 gigabytes, 4 gigabytes, 10 gigabytes per month of high-speed 4G LTE traffic. Once you exceed that, the phone company either charges you more, shuts you off, or puts you down on a 3G network, which is often not fast enough for viewing most modern websites. So you got to be careful that you're not chewing up your customer's bandwidth with images, videos, ads that are not meaningful. So you want to build what's often called lightweight web pages. We'll talk more about that later on. So let's step back for a second to what we need to be concerned about this semester. So what we want to do is we want to go ahead and develop websites. We want to develop web pages. So what we need to be able to do is have a program that allows us to edit HTML files and HTML documents. We need to have a place to store those documents on a web server and therefore, quote, publish them. And we need to be able to register that web server under a domain name. How do we do this? Well, we're going to use multiple combinations of programs, services, and programs. That's referred to in computer science as a stack, a programming stack. Now, we're going to use Weebly. It's a platform that is commercial, but has a very good free account mechanism to edit our HTML files in a very nice, very user-friendly browser-based editor that does not require you install any programs, and it works the same way on the PC as it works on the Mac. We're going to use Weebly to host our website, so they're actually going to provide our web server, and they're going to provide our domain name registration. And the good news is they have a free account that we're going to create in the lab that allows us to create websites with up to 10 pages. It has some other limitations, but for all intents and purposes, it's good enough for us. However, Weebly has some significant restrictions when it comes to building dynamic content. Like most other platforms, they really want you to stick within their environment. So we're going to leverage a second stack, and we're going to use a pure web hosting service called a WordSpace, which allows us to edit files, again, within their editor in the cloud, so we don't have to install anything. They will host our website, but we will have to program everything in pure HTML. So we're going to use two stacks, the Weebly stack and the WordSpace stack. We're actually going to show you how you can integrate the two to build what we often call mashups. And in fact, it's very common today that you're going to construct web pages by including content and widgets and controls from lots of other websites and web platforms. So we're going to make copious use of that. Now, before we conclude with this, there's one more issue that we have to briefly address. We'll address this in much more detail later on, but we have to briefly talk about the notion of search engines. Once you build your website, somebody has to be able to get to it. So, of course, if you publish the URL of your website and you put in your business card, you put in your Facebook postings, you email it to your customers, well, of course, they know what your web engine is. But what do you do if you want others to be able to find your website and they don't know the URL of your website? How do they find you? I mean, think about, how do you find companies? Well, you go to Google. You go to what's called a search engine. You go to Google and type in, I'm looking for best places to buy German food in southern Florida. And Google then will go ahead and look through a database. Now, Google has amassed a database of all pages on virtually all websites in the world. They have an absolutely massive database. And they take those pages and they index them by keywords. So when you type in a keyword, best German food in southern Florida, it will look through all the web pages it has in its database and look for those web pages that match what you're looking for. Now, of course, it does very smart keyword searching. It doesn't just look for German, food, and Southern Florida. It looks for things based on your location, based on previous searches. In fact, in the case of Google, also looks through your email, looks at your IP address of where you're located, and it kind of tries to figure out what is most relevant to you. And then it displays your most relevant pages. So if you go to Google, like in this case right here, you type in best German food, South Florida, you are now sending a request to Google to run a program to search through its database for websites that match your query, that match your question. Now notice it found 11,200,000 results. So it basically has about 11.2 million pages in its database that match your criteria. It searched its entire database in 0.73 seconds, which, by the way, is stunning in its own right. That's just absolutely incredible in how fast it can do that. And then it displays them to you in list of what it considers to be the order of relevance. Now, whether you agree with that being the right order is up to you. Of course, by the way, this is the search results from Google. You could have also gone to Microsoft's search engine, which is Bing, type in the same query, it would have also searched its database. Now, Bing only found 2.4 million results. Now, that could be that because maybe it has a smaller database, less likely, or more likely because it has managed its pages better. So it only looks for truly relevant pages. And it gives you its results, which, by the way, may not necessarily be the same as Google. It has a different ranking algorithm, a different way of deciding what is most relevant to you. Now, we'll talk more about search engines later on. But that is actually how ultimately your page will be found by your customers. So how do you get into a search engine? Well, the good news is there's not really much you have to do. When you publish your web page, at some point in time, typically relatively quickly, Google and Bing and Yahoo will find your page. They run crawlers with spider programs 24 hours a day, 7 days a week, and they run through the web, and they always look for new pages or pages that have changed since the last time they were visited. And they look for the pages and put them into its database. And then rank the pages based on their algorithm. Now, again, we're going to talk later on about what those algorithms are and what you might be able to do as a web page designer, as a developer, to encourage Google and Bing and Yahoo to place your web page higher up in the ranking. That is referred to often as SEO, or search engine optimization. It is a little bit of sort of black magic and dark art, but there are some things you can do, and we'll have an entire chapter on that later on. So for now, just to sort of wrap this up, we've now talked a little bit about how you physically connect to the network, how the web works as a client-server architecture, what programming languages you need to build web pages, and what programming stacks you need to be able to do this in practice. We're going to restrict ourselves in this course to a relatively easy stack that will satisfy the majority of web development needs for small companies. Bigger companies like an Amazon, hotels, travel sites, and so on, well, they typically do all of their development in a custom fashion. They use high-end web services like Amazon's web services, Microsoft's Azure Cloud, and so on. That requires some pretty significant programming expertise that's beyond the scope of this course. But what we can do is really show you how to use HTML, simple stacks, some simple PHP, some simple JavaScript to build some quite interesting, very responsive websites. So now you're ready actually to attack assignment 1 and start to create your Weebly account, start to become familiar with the Weebly platform, and then we're going to start building on top of that. Now, any questions you might have on this topic, make sure that you post those to the discussion forum, and make sure that you ask your questions initially on the forum so that we have a place where we keep answers, so in case others have the same question, we don't have to repeat ourselves in explaining the answers.